So the interesting thing about being in a worldwide role in IBM is it really just means I get to travel more, and I get to travel all over the state and the New England region, and that's primarily my function is to actually interact with our clients and with our partners around the world, and actually act as a point of intersection for bringing actually intelligence and bringing insights about where our customers are actually achieving results, achieving positive results, and actually delivering value. So in this particular presentation, the goal is not necessarily to spell out what big data is, but more to give you a feel for IBM's perspective on big data, give you a feel for where we're investing, what we're actually doing in research and development, where we're trying to innovate and help our customers, what's actually driving our strategy around big data, and then actually give you a feel for what's available today, a little bit of what's going to be available tomorrow, and then I think more importantly, talk about what our customers are trying to actually accomplish with big data technologies, with big data techniques, because it's not just about technology, it's about a new approach to potentially analytics. And we'll talk a little bit about some use cases and some actual examples of where customers have actually achieved those results. So, just to kick off, to actually think about, why is this hot? Why is this actually such a big topic? Well, a lot of customers have taken the last, 10 years, maybe, 15 years, come to the realization that data and information in their organizations is actually an enterprise asset, right? We've all matured to a point where, we have data governance, we recognize that the value of actually information is actually a strategic asset. And if we can leverage that asset, obviously we'll be better off. Well, what's really happening is organizations are now getting to a point where they're actually realizing that it's gone beyond just being an asset, it's now actually a resource. And if we can actually understand that data more effectively, if we can mine it, if we can refine it, if we can leverage it to further lengths, then actually it becomes more valuable. Okay? And a lot of people are referring to big data as sort of the new oil. Well, to put that into context, why haven't we considered this before? Well, if you think about the gold industry, and you go back 100 years, okay, when people started to mine for gold and the whole gold rush happened, in various parts of the US and around the world, it was very easy to find gold. It was very easy to find the value of gold, right? You'd walk up to a creek bed, you would sift through the gravel and the soil and the dirt, and by line of sight, you'd literally see the gold nuggets. And I sort of say that's akin to, a business user saying, I want a sales report. Okay, and we know we get the sales information from our transactional system. You have a line of sight to that informational value, right? You can make good business decisions from that data. And that information effectively represented 20% of our data set being that structured transactional data. And that's like mining 100 years ago. But as that gold became less and less evident, less and less easy to find, obviously it became harder to extract that value. Fast forward 100 years, we're still producing a lot of gold, but technology has actually enabled that. Technology has come to a point where we can actually mine for gold at a much lower level of granularity and extract traces of gold out of soil. And to do that, as you can see, we have these large open pit mines where we're extracting tonnage of dirt and soil, and we're actually using very sophisticated technology and techniques to extract those trace elements of gold from the soil. I mean, the next generation of this, right, is going to be the oceans, because there's actually gold in the water in the ocean, and they're going to evolve to a point where we're actually going to start to extract gold from water, which is hard to believe. And if you sort of start to put that into context, right, world production of gold, back in the early 1900s was about 380 odd cubic tons, right? Now we're actually producing 2,400 tons of gold a year. Now, yes, production has increased, and obviously, we're investing more in extracting gold, but it's really attributed to these new techniques and these new technologies. And this sort of underpins the whole concept of big data. You see, if we can go and start to look at more data, okay, leverage new technologies, leverage new techniques, okay, new ways of doing analytics, what's the value potentially buried there within our existing enterprise, information architectures and so forth. So what are the possibilities, right? Here are some examples where some of our customers have either addressed a challenge, okay, or they've unlocked an opportunity. And I think you've got to think of it in those two sort of categories. Do we actually have a challenge, okay, an SLA problem? Do we have a problem in regards to meeting, the requirements of the business? Do we have a cost of computing problem, a cost of storage problem? Okay, can we not crunch the numbers fast enough to actually, meet the business objectives? Okay, that's the challenge. Or can we potentially unlock an opportunity? Can we find new insights? Can we change the way we bring products to market? Can we change the way we actually deliver customer service? Can we actually find new markets? Can we find new products and services to deliver? Okay, that's the opportunity that really is represented by a lot of the market hype around big data. Okay, organisations are starting to leverage this type of analytics to really change the way they operate within their particular industry. And the ones who have done it well in the last 2 or 3 years are actually the ones changing the industry as a whole. Okay, and they're actually changing the game for all of their other competitors. So, we talk about, once again, what are the characteristics of big data, and I'm sure a lot of you have seen the analyst reports and lots of blog entries and lots of information out there in the media around the 3 V's or the 4 V's or the 5 V's. Okay, and these V's are important. Okay, yes, there's volume, yes, there's variety, and yes, there's velocity of data. Okay, but I think it's important to understand what these really truly mean, because a lot of my customers, and as I said, I travel around the world and I travel to smaller countries. Okay, smaller customers that have less of a customer base themselves. And their first objection is, well, I don't have big data. I don't have zettabytes of information. I don't have petabytes of information. I barely have terabytes of information, right? So why is this relevant to me? Okay, that's a pretty common objection or question that you pose. Well, if you think about this, it's not just the fact that information is growing. Yeah, that's a reality and that is a problem for a lot of our customers. But it's a question of, what can I do if I look at more information that I potentially don't look at today? Okay, so to give you an example, go back 10 years when I was in the data warehousing industry, and data governance was emerging as a concept. I had a conversation once with the CIO about the quality of their data warehouse. And before the meeting got started and we started warming up, she said, well, we don't have any data qualities in our data warehouse. Our data in our data warehouse is 100% quality, right? No errors, no problems, nothing whatsoever. I said, okay, that's interesting. So how's that working out for you? She said, well, we only report on 80% of our business because we reject 20% of our data. Okay? So this concept of not being able to look at all of your information, only looking at, for example, structured data within your enterprise, okay, is really creating blind spots. So if you could look at more information, what potentially could you unlock in regards to the way you operate your business? We'll get into that in a little bit more detail. Velocity. Yes, information is being generated faster. Yes, the fact that everything's being instrumented, we have devices, we have RFID, our manufacturing lines produce more information than we know what to do with, and so forth, right? Yes, customers email us constantly, they get on live chat, they get on our e-commerce environment and they're interacting with us. And a lot of information is being created at a very high velocity. But this is really a case of, what could we do if we actually were able to understand information and actually extract insights from it in the moment, okay, instead of after the fact? How can we change the game then? How could we change the game if we could respond to a customer as they're interacting with us right now versus calling them up after the fact? How can we change the game if we're producing goods in a manufacturing process and we're able to divert those goods to an alternative step if we identify our quality issue? How can we change the game, for example, in healthcare, if we're able to identify and diagnose a symptom before the actual symptom presents itself, okay, as an example. So how quickly can we actually react and actually identify those insights is really a way of changing, the game for a lot of industries. And then, lastly, obviously variety. Okay, I've spoken a little bit about that gold analogy, okay, being that structured data that, you can see line of sight. Well, a lot of organisations aren't actually including it in their analytics or their information business intelligence environments. Okay, the unstructured data, the 80% of the data that are represented by either content or by either logs or by any other information that traditionally hasn't been deemed to be high value or structure. And that's where, once again, a significant movement around big data is can we look at more information, new types of information that we haven't considered to be of value before, bring that in, and then start to leverage that. And then lastly, veracity, okay, governance. Okay, just because we're looking at more information, we're looking at it faster, we're looking at more types of information, doesn't necessarily mean it's going to always produce the right answer. Okay, doesn't necessarily mean we're always going to be able to trust it. So you can't necessarily throw the baby out with the bathwater around big data. You still need an ability to govern that data. You still need an ability to ensure it's secure, okay, that it can be trusted, and that you have, the right business and technical definitions associated with that. So what types of data are we talking about? Okay, this is how IBM starts to categorize sort of the information that we're really referring to in regards to this unstructured data, or potentially the types of structured data. So here's that 20% that people always refer to. This is the transactional data. This is the supply chain system. This is the call center system. This is the OLTP system, and so forth. This is the data that we've largely spent the last 20 years analysing to death, okay, and answering the business questions. Now, what organisations are looking at is, can we bring in other types of data into our analytics and our business intelligence environment that potentially enrich and add value? Okay, so machine data. Okay, data exhaust for a lot of people. This is the data that applications and systems and machines spew out constantly. Okay, this could be as simple as clickstream data coming from your website. Okay, is really machine data as an example. This is data coming from your manufacturing systems, or potentially from all of the instrumentation in a hospital. Okay, yes, it's important data, but do you really look at every single event of a monitoring sensor, or do you just look at the alerts as one example? Okay. Social data obviously is a significant driver of big data. Okay, and mobility has now become the platform. I saw a statistic the other day that mobile devices, smart devices and so forth have actually passed PCs in regards to how many people are connecting to the internet, and the infrastructure. So clearly social data, bringing that information in. And then lastly, something that I think a lot of organisations forget to consider, enterprise content. Yes, we have content management systems. Yes, we have records management systems. Okay, we have systems to manage this content. But are we actually extracting value from that data outside of the core process? Okay, so I'm an insurance client like everyone else in this room. When I moved to the US, obviously I had to figure everything out. It's a little bit different to Australia. But insuring my house, insuring my cars, insuring whatever assets I may have, I filled in a lot of paperwork. Okay, and there was a lot of sub-policies and flood damage and mold damage and mildew damage and all sorts of insurance components. That's all buried within documents within my policy. When I ring up and I want to make a change, generally my agent has to dig all that information out and make that change. Okay. A lot of insurance firms are starting to mine that with text analytics to extract that information out, to use it for their major analytics around what would happen in the event of a flood, what would happen in the event of a particular storm or a severe event. So you start to think about those data types, and then you have to start to think about, well, how are we actually going to manage that data? How are we actually going to process that data? And that starts to create a need for new technologies, okay? Some innovation. So clearly, if we're looking at a variety of data sources, maybe we need a new way to go after and find this information. If it's not sitting within one single system, maybe we need an ability to search for this data. Maybe we need an ability to navigate it and discover it and actually do some quick analysis. Okay, if we start to look at collecting more information, okay, here's obviously a significant driver of big data. We need a really cheap and cost-effective way to store it. Okay? Something that we can justify because we don't necessarily know if the value of this information is going to be real or not. Okay, so this is one of the primary drivers behind the adoption of Hadoop. Okay, a lot of this information doesn't actually represent value, but we still need to store it to actually make that determination. And we may not know its value today, but potentially it might give us value in a year's time or 5 years' time or sometime in the future. And obviously we still also need a quick and efficient way to actually analyse that information, to actually compute it. And then there's a series of other capabilities. Obviously the data warehouse remains a critical component of a big data environment or a big data architecture. In fact, most of the use cases that we get engaged with our customers is some sort of extension of a data warehousing activity, or it's a core data warehousing activity itself, where you're leveraging big data technologies like Onetezza that we'll learn about today to accelerate, okay, to actually accelerate those techniques and those analytical workflows. And then there are other capabilities around stream computing and text analytics, okay, and so forth, that all become real critical building blocks depending on the type of use case or the type of data that you're going after, that all become really critical capabilities. So this is very much a technology view of what might I need or what potentially can I leverage to go after a big data challenge or an opportunity. But one piece that I think a lot of us forget, it's not just about technology. Okay? Yes, we're all technologists, and yes, technology is great. But actually, big data also represents a new approach, a new technique, a new way of thinking about data. And this is one of the biggest challenges a lot of organisations face, is how do we change culturally, how do we change our processes to actually take advantage of this potential opportunity. Okay? And in a lot of the discussions I see with sort of C-suite executives, okay, or directors or managers of certain lines of businesses, they're actually looking at big data as a way to break from potential tradition, okay, the rigor of tradition that we've built into the system. Okay, and it's sort of a change agent for them. Okay. And the classic examples that I hear are, it takes 6 weeks to 6 months to introduce new data into our analytical environment. Okay? Or it takes enormous amount of time and manpower to potentially prove value of an idea before we actually extract value from that information. And what a lot of organisations are looking at is, can we introduce a more exploratory, iterative, experimental approach to some of our analytics that doesn't necessarily sort of prereq or require the rigor and structure of our traditional data warehousing activities. Can we potentially load data quick, do some analysis, get a result, and move on? Can we get an environment where we just land the data and give someone the capability to explore that and actually experiment? A colleague of mine actually came up with a recent blog entry where he said, we've forgotten about the R in the R&D, because a lot of organisations manage projects for success, right? It's all about success. We need to deliver on the requirements, we need to deliver on time, we need to make sure we deliver success. I mean, how many of you are allocating within your budget, within your projects, actually time for failure, for experimentation, okay, for research? Okay, no specific requirement, no specific deliverable. Okay, just go off and try and find something new. Okay, a lot of organisations have forgotten the value of that. Okay, and this is actually one of the other aspects of big data. It represents a new approach. It sort of breaks a little bit away from the sort of the rigor that we've become accustomed to around business intelligence and around data warehousing and analytics. So we've actually seen this before, and this is one of the key areas that IBM is using to drive its strategy, is that, we think back to the 60s, right? There was this need for high volume transactional, workload capabilities. Airline systems were emerging, online transactional systems were really starting to scale up and so forth. And, IBM obviously invented the mainframe and various technologies around the mainframe platform to support this, okay? To support this demand in these high volume transactional systems. And then in the 90s, another class of applications were starting to emerge, right? The whole web of things, B2C, B2B, and so forth, e-commerce, where people wanted to land a web page. From a web page, they wanted to have an online catalogue. From an online catalogue, they wanted to obviously be able to transact and collect payments and so forth. Okay? And obviously, IBM once again saw this class of new applications emerging, and we came up with the application server. We'll step into that in a little bit of detail. We're actually seeing the next class of applications, the next class of analytical applications centered around big data, and this is actually a model that we're following, and it's driving a lot of our investment and research and development in this particular area. So let's break that down a little bit and what we mean by that. So if we take the web application server, the web environment as an example, the enterprise in the world were inventing new applications. Portals, websites, e-commerce, transactional systems and so forth. Okay? That was the class of applications that people were innovating around. That obviously created a need for new capabilities. We needed a development environment. We needed an environment to host the actual applications. We needed capabilities around connecting that back to our transactional systems. And back to the mainframe, funnily enough, was where a lot of these web applications were actually being hosted from. And then obviously that created a need for new technologies. Some developed in the open source community. Okay? New standards were developed, new approaches to building these applications were developed. Some innovation happened, and obviously the commercial world around application servers. And what we ended up with is we ended up with a new stack for developing web-based applications on an application server, with the soup to nuts capabilities that you need. If you think about big data, the same pattern is emerging. New applications are being invented. Customers want to go after churn and risk management and fraud scoring and a whole host of very innovative use cases that really take what they do today to the next level. Okay? That's creating requirements for new capabilities. We need to deal with non-relational data. Okay? We need to be able to crunch data at a very cost-efficient equation. Okay? Those capabilities are obviously requiring new technologies. Clearly, the Hadoop and MapReduce and NoSQL-oriented databases, is at the forefront here. But also some innovation around hardware acceleration. Okay, and I think as you'll learn today, Onetezza was really ahead of the curve here, where they said, there needs to be the next leap, right? We need to go to the next level of analytics, and they introduced their hardware acceleration capabilities around the appliance. Stream computing is a key area as well. Okay? People are no longer happy that decisions are being made after the fact. They want decisions being made in the moment. And then clearly, that starts to create a requirement for a big data platform. And we're going to start to see that concept of a platform around big data capabilities to continue to evolve, but IBM, I think, has a pretty good handle on that. So this is our view of the world as it stands today. Okay, we see in the big data platform three sort of core computing environments. Okay? You've got your traditional data warehouse, appliance, analytical environment, okay, focused largely on the structured data, high volume, high analytical workloads, very low latency, analytics, okay, with agility. On the other side of that equation, on the left-hand side, we have your Hadoop-based infrastructure, okay, low-cost computing, low-cost storage, okay. No data model, highly unstructured, generally speaking. We want to go off and crunch numbers for large periods of time and come back with the result. Okay, and variations of that. And in the middle, we have the stream computing capability, where the concept is we want to analyze information as it's moving. We don't want to wait for it to be persisted to disk, and we don't necessarily want to have to force all of our data into a common data model to be able to analyze it. We want to mix audio, video, text, sensor data. We want to be able to analyze it all together at the same time. Across the top there, IBM sees a significant role for us to play is how do you actually leverage these computing capabilities? Okay. How do you actually start to accelerate and deliver the applications that you need? And with that, you get obviously into the application development capabilities, the system management capabilities over this infrastructure, and certainly the visualization and navigation capabilities to actually find the data you need, figure out how to analyze it, and actually produce a result. But a key goal of ours is to support some very common use cases in this architecture, in the sense of whether you're starting with a highly unstructured Hadoop-based platform, or you're starting with a highly structured analytical appliance in a data warehouse platform, when you actually look at historical data and you figure out what that model is, what those predictors are, what that signal is in the noise, you then want to potentially operationalize that in a stream computing model. And we see this platform supporting very much a closed loop mechanism, where it doesn't matter where you do the analytics, it doesn't matter where you discover the rule, the model, the signal, you can actually re-execute that anywhere within the computing environment and be very flexible about that. So the goal is to not lock you in one computing paradigm, but to facilitate you to move from computing paradigm to computing paradigm based on the particular problem you're going after. Okay? Alright, so the point is, you don't have to necessarily start in all of these environments, but if you start in the data warehouse, we want to enable you through common tooling and common integration capabilities and common analytics to evolve into potentially the other computing paradigms when the requirements or when you see the opportunity present itself. We spoke a little bit about governance earlier. Clearly, a big data platform, just like the application server, isn't going to exist in its own little silo. It's not going to sit over there in the corner of the room, right? It needs to be integrated back into the rest of the enterprise. Okay? It needs to integrate with your transactional systems. It needs to integrate with your content systems. It needs to integrate with MDM as a key example. Okay? Master data plays a big role in a big data initiative. And likewise, you need to be able to govern it. Okay, one example of why governance is important is a lot of our customers are looking to implement things like location-based services. Understanding where you are within the world, and then ensuring that the services they provide you as a customer are relevant, or potentially new services that they might be delivering you are potentially of interest. So once you start tracking location, for some use cases it's okay for you to actually know that Stewart here is in the West. Okay? For other use cases it's not okay for you to know where I am. And you need to be able to secure that information and govern it appropriately. And then lastly, the big data platform needs to work within a broader ecosystem. Okay? It needs to support our existing business intelligence tools. It needs to support our existing statistical and mathematical tools, our mining tools. It needs to support our content applications, or potentially other applications that are going to leverage the insights that you might glean from looking at these new data types and computing it in a different way. So this is our view of the world, and this wasn't meant to be a product pitch, okay? But clearly IBM has product capabilities behind this, and the important aspect to realise is we see it as being a much broader solution and a much broader ecosystem that you need to take into consideration as you start to think about big data. It's not a Hadoop problem. Hadoop is, it's topical for various reasons, but big data is not just about Hadoop. So use cases, okay? Pretty much, I can sit down with my 12-year-old and think up big data use cases, okay? This is actually part of the challenge. The use cases could be very wide, very broad, depending on your particular industry. I was at a New York conference the other day up in Albany, and I was sitting down at a table and the conference was getting underway, and just introducing yourself to people, and someone found out that I was from IBM, and I was here to talk about big data. And she said to me, so what's big data? I don't really get it. And I said, okay, so what do you do? And she said, well, I work for the tax authority. I said, well, what specifically do you? Well, I manage road tax. Okay? I'm responsible for collecting road tax. And I said, okay, so what challenges are you working on? She says, well, challenge right now is how do we think up new ways to collect revenue for road tax, or for road maintenance and so forth, where we understand that road usage is changing. Okay, no longer is it viable to collect tax through just the purchase of gasoline. We're finding that cars use less gasoline, so revenues are declining. We're finding that people are now using cars that are hybrids or using alternative energy, so they're no longer potentially going to be buying a lot of gasoline in the future. So that's another changing dynamic. And she was specifically working on an initiative to think about what do they do in the next 5 to 10 years to potentially collect revenue where people aren't necessarily buying the same amount of gasoline anymore. And I said, that's a big data problem. And she says, how? I said, well, you're going to figure out how to look at more information beyond the transactional data of a gas purchase to figure out how you're going to actually track people's car usage on the roads to augment your revenue. She said, okay. That's the sort of creative thinking that you have to start to potentially embark on to look at and leverage big data. Yes, there are common use cases, okay? Data mining and data storing, whether it be for risk, for fraud, okay, for healthcare, is very, very common. Whether it be potentially next best action, being able to analyze data across multiple channels within your enterprise, okay, and actually making the determination what's the next right thing to do for this particular interaction. Yes, there's a huge amount of use cases in industries where they have a lot of infrastructure, telecommunications, oil and gas, energy, electricity, and so forth, manufacturing. Okay, they have a lot of that machine data, the network, the infrastructure generates a lot of data that they haven't traditionally leveraged. Okay? In telecommunication, yes, every time I make a phone call, they generate a billing record, right? But are they really leveraging the fact that, I'm on Facebook, or I'm listening to Pandora music, or I'm potentially traveling, or I'm using a traffic application down I-90 this morning? Are they really leveraging that information to the best advantage? Telco call revenue is dropping. Telco data usage is rising. They're not making money off data usage, right? And it's a major business problem for them. So a couple of use cases, or I guess success stories, some case studies, giving an indication of where our customers are leveraging these type of technologies and techniques. Okay, I'm going to continue to repeat that, right? People don't realize it's not just a technology problem. How do we change the way we do things? And yeah, a lot of big data technologies were actually invented in collaboration with the US government. Some of our core technology was actually developed specifically on the back of the sad events of 9/11. Okay, we can certainly delve into those details. So they're a big customer of ours. But in this particular scenario, they had a problem of analysing data from an optical cable that was developed by the Navy, being able to correlate that data with video, being able to correlate that data with other sensory inputs, and actually determine the threat level of a perimeter around sites of national interest. And they actually create various threat levels depending on the distance and the speed at which an object might be travelling to that site. And they do that all in real time, all in the moment. And they're using our streaming engine for that, and they're now using some of our data warehousing appliance technology to actually bring in and analyse more information over longer periods of time. Huge success story. Healthcare, okay, another key industry for us beyond defence and security. Okay, University of Ontario is actually quite a popular success of ours, and if you've ever been on YouTube and you Google data baby, this is the actual success story. Where this is a really good example of innovation. So if you're on a critical care unit, and this example is around premature babies, right? They've got sensors, and the baby's obviously connected up to all of those sensors, and these things will raise alerts when something goes wrong. Okay, baby's heart rate drops critically or speeds up. Baby's temperature might drop or pass some sort of threshold, right? This is that classic scenario. I have a rule, min and a max. If I pass that, raise an alert. Okay, we all know this scenario. Well, the human baby, is a very complex system. Okay, it represents any other complex system in our ecosystem, whether it be e-commerce or any other aspects of our business. And yeah, the alerts are important, but you tend to become numb to those alerts. The doctors and nurses become really numb to those alerts going on all the time. A lot of false positives, a lot of false negatives, and so forth. So in this scenario, after some research, they discovered that it wasn't necessarily the mins and the maxes and those alerts that they needed to monitor. They needed to monitor the lack of a signal, the lack of change. Okay? And the way they figured this out was, if a baby's heart rate doesn't change to a certain pattern over 24 hours, then there's a problem. If the baby's heart rate actually remains constant when it sleeps and constant when it wakes up, then there's a problem. Okay, so what they determined was the lack of a signal was actually the indicator to a problem. So now they have a system where they're analysing all this information in real time, and they're able to actually detect the early onset of a potential healthcare problem in these babies 24 to 48 hours earlier than previously they could before. So they're actually really saving lives. And who's going to IOD, our global conference, in a couple of weeks in Las Vegas? Is anyone attending? So in a couple of days, hopefully you'll see a press release around another hospital making a similar announcement around head trauma. Similar technology, similar approach, but basically revolutionising the way they monitor patients with head trauma. And it's quite topical for me because my son just had a concussion and he had 8 staples removed from his head. So this is something that I'm actually quite keen to learn more about. Telcos, spoke about telcos. They're at the front of big data. They're still struggling to deal with 3G generated data volumes, let alone LTE and 4G generated data volumes. So we talk about zettabytes of information, this huge growth. They have literally charts that go off the page. 30–40% volume in data generated on a quarter-by-quarter basis. So they really have that problem. In this particular scenario, this particular telco had an issue around meeting their SLAs. and they implemented a solution actually in combination of Onetezza as well as our stream computing platform to actually be able to load the data that's being generated on the network in less than 10% of the time that it was traditionally taking their existing techniques. Okay, so not only have they now changed the way they collect and integrate to store data for analytics, but now that they're instrumented with this system, the next series of use cases are going to be very familiar to us with our other telco successes, and they're now starting to implement the analytics to identify when bad things happen in the network, okay, and then actually be able to be responsive to those in real time when they happen. Okay, Carter Zing, okay, a very popular retailer, okay, had a problem around, it's a very simple problem around meeting their SLAs, supporting the changing dynamics of the analytics that they wanted to implement. Okay, they couldn't integrate and correlate across their various lines of businesses and so forth. Okay, and they had a cost of computing problem. They had an issue around the manpower required to address this issue. And they actually implemented Onetezza. And the one thing I like about this story is it's very rare to see an implementation of a new technology, particularly replacing an existing technology, happen in like less than 6 weeks. Right? That just doesn't happen. Okay, it sort of speaks to the simplicity of Onetezza. But not only could they do that, but then they radically changed the way they could compute this data. You start to crunch the numbers down into these sorts of reductions. Okay, you think about the opportunity it starts to unlock. Okay, the ability to actually start to free up people's capital, okay, and the computing capital, actually start to think about the next generation of opportunities we want to unlock. University of Southern California, okay, I've introduced this one. This is a good representation of what we're actually doing with a large number of clients that don't necessarily want to talk publicly about what they're using social media for. Okay? So social media obviously is the poster child for big data. Can we analyze the tweets and the Facebook entries and the blogs and the microblogs and all this information and actually figure out what our customers are doing? Or in some of our client examples, they're actually not too concerned about their customers. They want to figure out what the market's doing and they want to figure out what their competitors are doing. They're using it for market intelligence. Okay. So in this scenario, USC has actually implemented a system that actually monitors sort of the film and movie industry and monitoring what's happening around the Oscars. They're able to predict, actually pre-predict, who's going to win the Oscars in this particular scenario. So we actually engaged with a couple of the studios to actually leverage this type of approach to be able to support their marketing efforts around the release of their new movies. Okay, so the example is you release the trailer and engage the sentiment feedback of the people who are potentially interested in that movie. And then what they can do is, they're still in the editing phase. They can either re-release a different trailer, they can change their marketing campaign, they can potentially look to appeal to a different demographic, or in some cases, they can rewrite the ending of the movie. Okay? They're at that point in time when they still have an opportunity to change the movie to a degree to respond to what the early feedback is. Okay, so some of our studios are starting to leverage this technology. And clearly social media goes across all industries. Whether it be insurance, banking, retail, telco, manufacturing, we're seeing this use case obviously play out quite commonly. Procter & Gamble is another variation where their challenge was the quantity of systems that they had, the quantity of structured, unstructured data that they had within their environment. They couldn't get that information to the right people at the right time, for the right purpose. So in this scenario, they actually implemented the Vissimo Velocity, which is some of the new technology IBM actually acquired recently, around providing the ability to search and navigate and discover data, okay, and integrate that data and start to work with it before you actually have to unload it and load it into a new system, okay? Because that's really, obviously, a huge burden to undertake when you're not really sure whether some of this information is all value or not. So they've actually really changed the way they enable employees to go after and actually be productive. And in some of the other scenarios here, I think Verizon is probably one of the favorite ones I have, where this technology is being deployed to about 40,000 call center representatives to enable those call center representatives to get access to that right information. NISIS, is another really good example, once again, where like a large number of organizations, the volume of transactional data clearly is exceeding their ability to compute that and so forth. So in this scenario, once again, they went off and addressed that traditional data warehousing problem, right? Their SLAs were being exceeded. Not only were their SLAs being exceeded, but they couldn't actually afford time to understand this information in more meaningful ways. They couldn't innovate. So in this scenario, once again, they implemented the NetEase appliance. Not only are they now able to store the quantity of information that they need, but they're able to compute that in record times effectively and changing the way they implement their auditory and securities analytics. And then the last couple of scenarios, healthcare I think is probably also one of those industries at the forefront, right? Leveraging big data. In this particular one in Asia, it's in a very large, geographically dispersed environment. Experts aren't available in every single hospital, every single facility. And so what they're actually implementing is a large system based on Hadoop, where they're collecting imagery data, okay, and they're actually implementing in the analytics a level of clinical review of this imaging data to actually help the doctors in this large geographically dispersed environment to actually get past that first level of assessment, okay? And then through the system, they're empowering the experts to actually interact with those doctors to actually help them with their diagnostics and diagnosis and so forth. And this is very, very similar to the scenario of Watson that IBM invented around the Jeopardy game, right? How do we actually take technology and push it out and make people a little bit more productive, a little bit more effective in certainly in healthcare and ensuring better patient outcomes? And then traffic, one of my favourite ones, particularly today since I sat on I-90 for about 2 hours. But traffic is one of those things that it's a major problem for a lot of industries. So whether it be Dublin, or whether it be Stockholm, or whether it be Singapore, actually in the very near future, where they're changing the way they manage the public traffic system, they change the way they manage tolls. And this is just a representation of a number of services that governments are starting to implement, where they're basically widening the aperture of information that they analyse and leverage that information to provide better services to the community. This is another very good example of taking big data and applying it to well-known problems. It's not like traffic's a new problem, but trying to innovate and change the way they address that particular issue. And I believe this is my last one, coming back to telecommunications. T-Mobile is a very good success story for us, a very good use case. In fact, telecommunications, as I said, is at the forefront of big data given their volumes. But in this scenario, just another example of that platform approach that I mentioned, where they started with one particular problem set and they're evolving into others. So in this particular scenario, they're leveraging once again the NetEase platform for helping them to manage the quality the quality of their infrastructure and the infrastructure themselves. But once they actually had that NetEase platform in place, they're starting to identify the signals in that data. They're actually identifying the predictive indicators of when something bad is going to happen. And they're actually now extending that implementation to leverage our stream computing platform to actually start to take some of those models and implement that on the system as it happens, okay, as it happens in real time. That's a very common scenario, a very common pattern that we see across a number of different industries. So that's an example of we solve the immediate problem, we potentially unlock the immediate opportunity, but then we start to evolve into the other areas that are relevant to sort of crunching big data. So just for the last sort of parting thought, okay, yes, there's technology behind this. Yes, the cost of computing has changed. Yes, there's a lot of innovation that allows us to do things that we haven't potentially been able to do before. But on the other side of that equation, you need to really think about how can we do things differently? Okay, how do we change the way we actually look at information? How do we actually give people the ability and the time to actually innovate? Okay, how do we actually give them that exploratory, innovative environment to sandbox really quickly, is there some value here, versus having to stand up a program at work to actually go off and do it. And I think that's the bit that we tend to forget sometimes as technologists around data, is that it's really the techniques and the change in the way we approach these problems and opportunities, plus the enabling technologies that sort of make it efficient and cost effective to do it, or just to do it at all, because the barriers are no longer So hopefully that has been informative, and I believe we do have plenty of time for Q&A later on. I'll be around for the afternoon to answer any questions on any topic. So thank you.